here's some examples where I'm going to talk through finding a reference angle for a given angle. So the important thing to remember while I'm talking through these is that a reference angle, by definition, is a positive. I have some trouble writing here. It's positive and it's acute. So it's positive and it's between 0 and 90 degrees. And it's always formed by the terminal side of the angle and the x-axis. Okay, I'm not going to write out the rest of that. So let's take these one at a time. So if your angle measures 205 degrees, so in this position up here, this represents 90 degrees. Over here, we've got 180 degrees once you rotate to the negative x-axis, and then once you rotate down to this negative y-axis down here, that's 270 degrees. So 205 degrees, you would be a bit past the 180 degrees here. That would be the terminal side. So the initial side, if it's in standard position, lies on the positive x-axis, and then we've revolved around to quadrant 3 here. So this is the angle theta. Now the reference angle, I'll draw in green, is always formed by the terminal side, so right here, and the x-axis, whichever side of the x-axis is closer, because the reference angle should be between 0 and 90 degrees. So in this case, this is the reference angle right here, which I'll put just a little, there's supposed to be a little hat on the theta there to represent the reference angle. Okay, so now we need to find the measure of this thing. When we revolve all the way over here, this is 205 degrees, and then the negative x-axis here represents 180 degrees. Then the green angle there is the difference between those two. So let me write it up here. So the little theta hat, the reference angle, will be 25 degrees, because that's the difference between 205 and 180 there. Okay, so let's look at this next one. Oops. Okay, so you always want to start these problems by giving yourself a rough graph to work off of. So negative 130 degrees. So negative angles, that means we're revolving in the clockwise direction. So revolving down here to the negative y-axis would be negative 90 degrees. And then once you get over here, this would be, oh, I did not mean to zoom in. I'm not good with this. So that would be negative 180 degrees. So negative 130, you would revolve, let's draw it. So starting from the positive x-axis in the negative direction, so clockwise, we would go past 90 degrees, keep going, but you would not get all the way to the negative 180. So it's somewhere in here. And when you're drawing your angle, I mean, you just have to make sure it lies in the right quadrant. Okay, now, so the reference angle is always formed by the terminal side, which is here, and the x-axis, which again, take whichever side of the x-axis is closer. So I'm going to use the negative x-axis again. This is the reference angle, so put the little theta hat there. So we need to find the measure of that angle. If this, here, this was negative 130, excuse me, negative 130 to get here. And then negative 180 would be all the way over to the negative x-axis, and the difference between those is 50. So the reference angle in this case is positive 50 degrees. We always make the reference angle positive. So you don't really worry with reference angles about, am I revolving this way or am I revolving this way? We just always make it positive. So it's just this angle here as a positive 50 degrees. So that's the answer to B. Now let me see if I can get this to zoom out. I don't. There we go. Great. Oh, and I didn't know all that would go away. Okay, now I know for next time. Okay, then let me summarize. Luckily, you guys can rewind. But here the reference angle was 25 degrees. Here the reference angle was 50 degrees. Okay, and then let me work on this last one on the first row. So 500 degrees. Now, if you revolve all the way around, that's 360 degrees. So we know it's going to be one full revolution and then some. So if you revolve another 90 degrees, if you add 90 to that, this would be 450 degrees. So actually, so we're going to hit 450 and keep going. If you add another 90 degrees, that would take you to 540. Okay, so we won't make it all the way back to the negative x-axis again. So you're going to stop somewhere in quadrant 2 there. So it's going to be somewhere around here for your terminal side. So imagine that you've started your initial side on the positive x-axis. You went all the way one complete lap and then around a little further to get to this angle here. So this is the angle theta. Now, reference angle is the angle formed by the terminal side and whichever side of the x-axis is closer, so it's going to be that negative x-axis again. So this is the reference angle right here. So to find the measure of that, let's see, so this was 500 degrees where we stopped. If we went all the way to the negative x-axis, that would be 540 degrees. So the reference angle here is the difference between those, so 40 degrees. That's the reference angle for C. Okay, 2 more because I wanted to do some in radians. So down here, let's say theta is 8 pi over 9. So here's 0 radians, here's pi over 2 radians, here's pi radians, which would be 9 pi over 9 if we wanted to write it with the same denominator as what we're working with here. So 8 pi over 9 is just a little short of that. So you're going to start your initial side on the positive x-axis. Terminal side will be, let's pretend that's a straight line over here somewhere. So this is the 8 pi over 9 angle. Reference angle is always formed by the terminal side and the x-axis, so that's this angle here would be the reference angle. So to find the measure of that angle, I keep forgetting to label the measure over here. This is 8 pi over 9. And then by the time you get to the negative x-axis here, that's 9 pi over 9. Then the reference angle is the difference between those, which would be 1 pi over 9. If you want to write out the arithmetic, it'd be 9 pi over 9. Okay, now the lag is starting here. Minus 8 pi over 9. So that gives you 1 pi over 9 for the reference angle on this one. Okay, last one. 17 pi over 10. So that's more than half of a pi, right? That's even more than a whole pi. Let's see, so because the pi radians back here at this position would correspond to 10 pi over 10, which were definitely more than that. By the time you get down here, that's 3 pi over 2. If you want to know how that compares with the 17 pi over 10, then you should get a common denominator. So I would multiply top and bottom by 5 here to get that common denominator. So 3 pi over 2 is equal to 15 pi over 10, this position down here. And so we've got 17 pi over 10, so we've got a little more than that. And then the 2 pi, when you rotate all the way back to the positive x-axis, would be 20 pi over 10. Right? If you multiply top and bottom of that by 10. So we're not getting that far. So this angle theta, revolving around here, so somewhere between the 15 pi over 10 and the 20 pi over 10, we're in here somewhere. This is 17 pi over 10. Oops, over 10. Now, so you have to draw a picture of your theta first, and then reference angle is the angle formed by the positive x-axis and the terminal side of the angle. So in this case, the reference angle is this one right here. So that's going to be the difference between 17 pi over 10 and 20 pi over 10. So the difference between those is 3 pi over 10. So that's the reference angle in this last example. The reference angle here is 3 pi over 10. Oops, 10.